All right, let's put on our detective hats. Our mission today? To crack the code of data. We're going to find the hidden stories buried inside a bunch of what looks like, well, just random numbers. Let's start the investigation.
I mean, let's be real. When you first look at it, a raw list of numbers is basically just static. It's a jumble of digits that doesn't really tell you anything on its own. It's a puzzle, just waiting for us to solve it.
So, here's the big question. How do we cut through all that noise to find the actual signal? How do we figure out the story the data is desperately trying to tell us? That's what we're here to figure out.
We're going to do it by using 5 essential, let's call them detective tools. These are the absolute fundamentals of descriptive statistics. And trust me, once you get these down, you'll be able to make sense of pretty much any data set that comes your way.
Okay, every good investigation needs a case file, right? So let's open ours up and see what puzzle we're trying to solve today.
And here it is. A local pizza joint wants to get a handle on its delivery times. We've got 5 data points, 25 minutes, 28, 30, 32, and then, whoa, look at this last one, 65 minutes. Our job is to figure out what's typically happening with their deliveries. First things first, we need to find the center of our data. We're looking for a single number that can kind of represent the typical delivery time. So let's pull out our first set of tools. Tool number 1 is the mean. You probably already know this one. It's just the average. Super straightforward. You just add up all the numbers and then divide by how many numbers you have. The key thing to remember about the mean, it uses every single piece of evidence in our data set. So for our pizza data, we add them all up, we divide by 5, and we get our first clue. The mean delivery time is 36 minutes. Case closed, right? Not so fast. Let's just pause for a second and think like detectives. Does 36 minutes really feel right? Look at our data again. 4 of the 5 deliveries were 32 minutes or less. So where in the world did 36 come from? Something feels a little off here. It seems we might have a misleading witness in our data. One of these numbers is telling a very different story than the rest, and it's kind of throwing off our whole investigation.
And this shows us the mean's one big weakness perfectly. It's super sensitive to outliers, those extreme weird values. That one 65-minute delivery, maybe the driver got lost, who knows, is pulling the entire average way up, giving us a really distorted picture of what's going on.
This is where our second tool becomes a hero, the median. To find it, you literally just line up your data from smallest to largest and pick the one that's sitting smack dab in the middle. And its superpower? It completely ignores those crazy outliers. So, for our pizza data, 25, 28, 30, 32, 65, the middle number is 30. Now, that feels much more like a typical delivery time. It's a way more reliable clue. We're getting closer to the real story now. So we found a typical delivery time, 30 minutes. Awesome, but that's really only half the story. If you're the pizza place owner, you also need to know, are the deliveries consistent? Are they always around 30 minutes, or are they all over the map? And this is why just knowing the center isn't enough. Look at these two teams. They could have the exact same average score, but Team A is super consistent, always clustered together. Team B, they are totally unpredictable. Same average, but completely different stories, right? To understand that difference, we need another tool. And that tool is the standard deviation. Now, it sounds a little technical, but all it really is a measure of spread. It tells us, on average, how far each data point is from the mean. Think of it like a numerical score for consistency. So how's it calculated? It's actually a pretty clever 4-step process. First, you figure out how far each data point is from the mean. Second, you square all those distances. This is a neat trick that makes all the values positive and gives a little more weight to the points that are really far out. Third, you take the average of those squared distances, and that gives you something called the variance. And finally, to get back to our original units, minutes in our case, you just take the square root of that variance, and boom, that's your standard deviation.
So here's the bottom line, the thing you really need to remember. A low standard deviation means your data is all huddled together. It's very consistent. A high standard deviation means your data is spread all over the place. Very inconsistent. Simple as that.
Okay, team, we've found the center, and we've measured the spread. We have our main clues. Now it's time to put it all together and see how these tools work together to crack the case wide open. And this is where the magic really happens. When your data has that classic bell shape,
The mean and the standard deviation become this amazing power couple. The empirical rule tells us that about 68% of our data will fall within one standard deviation of the mean. About 95% will be within two. This is incredibly powerful for making predictions and spotting when something is really unusual.
So here's a little cheat sheet of our detective tools. We've got the mean, which gives you the average value, but remember, it's sensitive to outliers. The median finds that true middle and is totally robust against them. We also have the mode, which just points to the most common value. We didn't have one in our pizza case, but it's good to know. And finally, for measuring spread, variance and standard deviation tell you how consistent your data is, but they are also influenced by outliers because they're based on the mean.
So why should you care about all of this? Because these simple tools are the absolute first step in any real data analysis. They let you understand your data's personality, they help you spot errors or really strange events, and they get your data all cleaned up and ready for more advanced stuff, like building machine learning models.
And that brings us to the most important takeaway. You just can't predict the future if you don't understand the present. You have to do this foundational work first. Describing your data isn't just a warm-up, it is the whole ballgame.
So we've just equipped you with the fundamental toolkit for any data investigation. You now have the keys to unlock the story that's hidden in all that noise. So the only question left is, what story will you uncover?